Thanks for coming. I appreciate that I'm keeping you from beer. So I appreciate that you've come along today and haven't sort of skipped this last session. I know it's been a long day full of learning, so thanks for joining me for this one. For those of you who've not met me before, my name is Grace Jansen, and I'm a developer advocate at IBM based in the UK. Dutch surname, but I don't speak any Dutch. So if there's any Dutchies in the room, sorry, please don't test me on that. Yeah, I see some shaking nods, sorry. Based in the UK, I mostly work with cloud-native Java technologies. So that can range from sort of runtimes all the way up to methodologies, supporting APIs. And I'm going to be touching on some of them within this presentation today. So what I wanted to explore within this presentation was how we can enable our applications to still be stateful even when we're using microservices and deploying them to the cloud, and how to do this in an effective manner. So first of all, the first thing to consider here is, why do we even care about this topic? Why do we care about making your applications best suited and effective within this cloud-native infrastructure? And that's because of this. Hopefully you guys are also Disney fans and you've seen this movie. If you've not, please go away and take this as homework. Go and watch Toy Story. It's awesome. But it's this excitement of, oh, the cloud. We get excited as developers by what the cloud can offer us. Things like cost reduction, things like flexibility, dynamic scaling, and all of the underlying infrastructure. So these behaviors are what gets us excited and sort of inspires us to be really creating applications that take best use of this underlying infrastructure. And to be able to create cloud-native apps, we often turn to methodologies like the 12-factor app methodology. You might also know the 15-factor app methodology as well. So in this, if you haven't seen it before, then go visit 12factor.net. It goes through each of these factors in a lot more detail. And essentially, what this does is lay out the key behaviors and characteristics that we should be demonstrating within our applications in order to be cloud-native. And there's a couple that I've highlighted. I've made it easy for you guys. I've literally highlighted them for you. You'll notice that in a couple of them, they say things like, treat backing services as attached resources, execute the app as one or more stateless processes. So we see this again and again in many of these methodologies, this sort of term of stateless and the fact that cloud-native applications sort of have to adopt this. And it means that we have sort of this assumption that in order to build cloud-native apps, we have to have stateless microservices. And this is kind of where I'm wondering, well, is this strictly true? Do we have to be stateless all the way through our application in order to be effective on the cloud? But the first thing we need to do before we go into whether we can or not, whether we should or not, is what do I even mean when I'm talking about stateless versus stateful? And for this, I turn back to Disney, because I'm a huge mega fan. And also, they're just great films. And hopefully many of you have seen them. So in this, we're turning back to Finding Nemo. Finding Nemo, for anyone who hasn't seen it, again, second piece of homework, please go and watch that, is a movie about a fish who gets lost in the ocean. And his dad, Marlin, on the left-hand side here, is looking for him with the help of his friend, Dory. And these characters are actually great representations in terms of behavior of what it means to be stateless versus stateful. We've got Marlin, the orange fish on the left here, who has a very good memory. Marlin can remember what's happened previously in his life, events that have unfolded, consequences of the actions placed when he's sort of reacted to those events. And so Marlin, when things are happening around him, is a little bit slower to respond. He often thinks through things before acting. And so when events are unfolding around him, he can be a bit slower in that regard because he's probably thinking through what consequences are going to happen based on previous events that he's seen. Whereas Dory, on the other hand, is very happy-go-lucky. For anyone who's not seen the movie, spoiler alert, she has a memory problem. The only thing Dory can remember is pretty much that she's a fish. So Dory is really responsive to events that happen around her because Dory isn't thinking about the consequences or what's happened in the past or previous events or memories. Dory just sees a jellyfish and thinks it's fun to jump. She doesn't necessarily think about the fact that she might get stung in the process. So Dory is a really great representation of stateless, and Marlin is a really great representation of stateful and the behaviors and characteristics that go with that. So going back to a more technical sort of definition of these terms,
What do we mean by stateless is really where we're not retaining any session information. So the state of the data doesn't get recorded between transactions. And what that means when it comes to architecture and design is that it can actually be a lot easier to scale and recover from potential failures or bottlenecks within your application, because you don't have to be thinking about reinitialization of any state within your microservices. You can bring them up fairly quickly and easily. And so that's kind of representative of that really responsive nature of Dory. And then we have stateful computing. So this is where the session is, the information is retained throughout the session. So basically we're storing the data at every step across all transactions. What this means when it comes to architecture and design is it can be a little bit trickier, a little bit more complex for things like scaling and also for recoverability, because you do have to be thinking about the reinitialization of the state within that microservice, for example. Again, it's a bit more like the slow nature of Marlin when it comes to responding to things. So you might be looking at this and thinking, well, looking at the definitions and the behaviors that I've described, Dory and those stateless microservices seem to be more aligned with cloud native. Why would we be building stateful microservices anyway? And what we need to turn back to and sort of reflect upon is the fact that our applications are really a reflection of tasks and activities that we want to carry out as we would within society ourselves. And actually, when you look at us as a society and the way that we interact, realistically, we live in a stateful world. For example, take the scenario where you have forgotten your spouse or your partner or your child or a friend's birthday. That's not going to go down well. At least it definitely wouldn't for me. So, we live in this world where we're not expected to be reliant on a diary to know when people's birthdays are, for example. We live in a world where we're expected to have this information to hand all the time. And so we can expect that at least some of our applications will be expected to have that state or will need some form of state within them. A really common example that's often used to demonstrate this is when you're trying to book a package holiday. So a holiday that includes things like accommodation, transport, whether that's flights or cars, etc., sort of transfers in between. So in order to book all of this, it's often needed that we need to have state throughout to be able to track whether that whole transaction can go through as a whole based on the availability of those microtransactions. And so this is often a common example used where we might still need to store state in our applications. So what about looking at sort of just lifting and shifting some of the technologies or techniques we might have used in the cloudless days, so before we were moving applications to the cloud? So let's take a look at some of those techniques that we might have previously used. So we might have previously been reliant on stateful database systems on the server side, and that includes things like what I just mentioned, so database-style transactions, often ACID-based transactions, and using sort of protocols like the two-phase commit to have consensus within those transactions. Now, I come from a biology background originally, so I like to make sure that if anyone isn't sort of aware of terms within my presentation, especially because in tech we use a hell of a lot of acronyms, I do try and define them. So if you're a whiz at transactions, bear with me for 2 minutes whilst I define it for anyone who's not. So what do I mean by transactions? Really, this is just a group of read and write operations that are only able to succeed if they're all able to succeed. So it's all or nothing, like with the package holiday. If I can't get a flight ticket, then I can't have my package holiday. Transactions can either impact a single record or they can impact multiple records. It really depends on what the transaction is and what microservices are involved, for example. And as I mentioned, traditionally, we might have used something like using the protocol of ACID, so ACID transactions, to design our transactions around these key behaviors. And ACID is another acronym. It stands for Atomic, Consistent, Isolated, and Durable. So this is really designed to be a guiding set of principles. And the key parts here are the fact that data has to be consistent, the data has to be performed or not at all, like most transactions, and no other process can change the data while the transaction is running. So it has this kind of resource locking that goes on to ensure that no other transactions can affect that process at the same time. So, and that these changes have to persist. So as I said, it's a guiding set of principles that are generally used in more traditional style of transactions. And it's really designed to guarantee that data validity, to really ensure that that transaction is able to go through and that you are ensuring that that's consistent throughout your application, this really strong consistency. In order to know whether a transaction can occur or not, so whether all of the microtransactions are going to be successful, we have something called a consensus protocol. So this is essentially usually a voting system where different components that are involved in those microtransactions can say whether they're able to succeed or not. And then we can get consensus, usually in a central coordinator of some kind, who then tracks all of these statuses or votes and is then able to say, yep, the overall transaction can go ahead or not. There are different kinds of consensus protocols you can use. One of the most simple and most commonly used is this 2PC, two-phase commit. You can also use things like three-phase commit, Paxos, Raft. There are a bunch of others that you can take a look at. But just for my example here, I'm just showcasing 2PC because it is one of the most commonly used. So in my example here, we have a holiday booking system. As I said, it's one of the most commonly used example applications for this. And in this, we have a front-end system that wants to book a holiday, so it sends a holiday request through. We have our coordinator in the center, which is what's coordinating all of that consensus for those protocols. And we're using 2PC, two-phase commit. And for this, we've got 3 microservices. We're going to be requesting a flight, accommodation in a hotel, and I'm going fancy. I'm getting a taxi rather than driving myself. So we've got the taxi microservice as well. So the problem with just lifting and shifting this into a more cloud-native application where everything is distributed is there are several issues with using ACID and 2PC in this regard. One of those is how slow it can be. You got to think about the fact that all of these resources are essentially locked and the transaction can't go ahead unless all of the consensuses are collected and are sort of able to go through from the various microservices that are involved. So you are limited by the slowest microservice involved in that transaction. And that depends on whether that microservice is responsive, is up, is available. And so it can be quite slow in terms of actually your speed of the overall transaction. Another issue that you might have is that you actually can't use two-phase commit with a NoSQL database. So if you're using something like Kafka or RabbitMQ, you can't use two-phase commit, which are tools that are kind of commonly used within cloud-native applications. So these are just 2 of the issues that we run into. Other ones include the fact that, you can see in my diagram, we've got a lot of communication that has to go on here, from the coordinator to the microservices and back again to get that consensus. And you're not using local communication anymore. We're now reliant on network communication for this to go between the various components of your application. And as a lot of us will know, if we're building cloud-native apps, that communication isn't always reliable, especially when you're reliant on sort of the cloud. Sometimes messages can get lost, sometimes they never get sent. How do you know whether that microservice received the message or whether the message was lost somewhere? Do you retry? What's your retry policy? So there's all these sort of factors to consider when it comes to communication failures. There's also the potential for your microservices to fail as well. It might be that they become unresponsive. It might be that your microservice goes down partway through trying to carry out this transaction. So then how do you know sort of what state they might be in, whether they've reserved that particular resource or not for this transaction? And you've got the issue that you're basically, again, limiting the speed of your application here if that were to go down. And there's also this potential issue of this coordinator in the center being a potential point of single failure or a bottleneck within your application. If that goes down, how do you know what the statuses are of your various microservices? And you've also got the issue that your transaction can't complete yet until that microservice comes back up. And in the meantime, you've locked all of these resources, so no other request can come in and utilize those either. So there's quite a few issues when we're considering just lifting and shifting this style of transaction into a cloud-native world. Other techniques that we might have previously used include things like sort of features on the actual Java language side. So utilizing things like enterprise Java beans, whether that's sort of session versus entity. So session being where it kind of stores data just within that session. So if your session were to go down, you'd lose that data. And entity beans where you can actually connect that to some form of external database of some kind to store that information. And we also had things like serverlets, for example. So we all know that using HTTP as a protocol is stateless in itself. So in order to be able to store state from that, you'll need to use something like serverlets to store that HTTP session. So, for example, on web applications, we might have used these to be able to maintain data during a HTTP session. Other ones also include things on the client side. So utilizing caching, for example, through cookies. Everyone's had that annoying message in your web browser about whether you want to accept the cookies, and you always have to click yes or no. So cookies are a great way for us to be able to store information about who is trying to access our systems, and to basically know when the same user is on the same website, for example, or utilizing your application. So to be able to personalize it, using things like basically carrying a session ID across. We've also got JWT, JSON Web Tokens is what it stands for, and this is essentially token-based authentication as opposed to cookies. It tends to be a little bit faster, for example, and it also enables us to transmit secure messages, and this carries with it, as well as the session ID, it carries a payload, which is why it can be a little bit quicker sometimes than things like cookies. But this, again, allows us to identify a particular user and access their session ID and sort of know all of that stuff and enable things like authentication. So these are what we might have used sort of 10, 20 years ago in our applications or in more traditional style applications. But what about what we'd use now, given the cloud native infrastructure? Can we use some of these techniques and tools? What can we use? How can we use them in a more cloud native manner? And a lot of you may be scratching your heads thinking, well, I'm still kind of stuck on this idea of how do we actually go from sort of having state within our microservices to making them cloud native when all of these methodologies say about stateless. And actually, for this, I decided to go back to sort of the original definition of what does it mean to be cloud native? What does cloud native computing really mean? And this is a term that was coined by Netflix back in like 2010-ish. So it is kind of biased by the fact that Netflix coined it themselves, so it kind of aligns with what they've done. But it serves a really good example of sort of the key behaviors that we're trying to strive to achieve here, which is really these needs at the bottom. So being highly available, being scalable, and being performant. That, at the very heart of it, is what it means to be cloud native. And it doesn't say in there that we have to be stateless or stateful. It just says these key behaviors. So bearing this in mind, we can perhaps revisit some of those tools and techniques and others that are more sort of built around cloud native infrastructure that can enable us to achieve this while still maintaining state. So how do we go about doing this using more cloud native tools? So we can still use several of the mechanisms that I've mentioned already, but there are there's an evolution that's occurred within these tools and mechanisms that are more aligned with cloud native and those behaviors that I just mentioned. So for example, with caching, we can still use this mechanism through things like Redis, for example. We can also use things like JCache, which is sort of the standard caching API for Java. And we can use that in collaboration with implementations like Hazelcast. And if you're interested in that, I have a demo app on it, which I'll link you to at the end. We can also still use database-style transactions, but use them in more of a cloud-native manner by relaxing the constraints of ACID transactions and using alternative guiding principles, which, again, we'll go on to in just a second. We can still use cookies. For example, Kubernetes, as one example, uses this idea of sort of sticky cookies, so utilizing it in more of the cloud-native infrastructure as opposed to perhaps client-side cookies themselves. And we can still use things like sessions and tokens. So for example, in the MicroProfile specification, they do have JWT as one of the APIs that you can use within your application. So that's kind of the techniques and methodologies. But as I mentioned, you can also use that underlying infrastructure as well. So utilizing the sort of features that are enabled by using tools and techniques like Kubernetes or container management systems. I just picked Kubernetes here because it's a very popular and one that many people know. So for example, you can use things like, for example, really utilize the fact that we have leaders and followers within Kubernetes and within things like Kafka, for example, where it enables us to have this resiliency because we've got duplicated stores of the state of your application. So if your leader were to go down, we can utilize the fact that it's got leader elections built into it to be able to automatically assign a new leader without losing that connection and without having to go down at any point and become unresponsive. And it enables us to ensure that we've still got replica versions of that so we can then keep that state. Also got things like stateful sets, for example. So stateful sets really are they help with managing the state of the data for all of your components at that infrastructure level. And it helps to organize things like the worker nodes within your system and sort of sync it up with other clusters within your cloud as well. And we can use that sort of combined with things like persistent volume. They work quite well together. So persistent volume really deals more at that storage level. So how do you actually manage the storage on your disk, for example? And then I've mentioned this already. We've also got cookies and session affinity. So being able to essentially, if the same microservice or user is trying to request the same process or the same request, for example, we can remember that and essentially assign it to the same node. So it saves time in terms of knowing what it needs for that particular request, initialization, and it enables us to keep sending that to that same node. So kind of similar in terms of having the cookies client side with that session ID, but this time within that cloud native infrastructure of Kubernetes. So this can be a really great tool to use as well. And as well as all of that, there's also sort of design patterns that we can encompass within our application design that can enable us to take advantage of sort of a more cloud-native approach to things like database-style transactions. So you guys, has anyone heard of Saga before? I've got some nods in the crowd. Great. Hands up. So yeah, so we've got Saga, and then in order to implement it, things like long-running actions. So Saga, again, this is really a failure management pattern. So it still is a sequence of local transactions, but this has been designed in a more cloud-native manner. As you can see here, really establishing consistency in distributed applications. So bearing that cloud-native manner in mind. And again, it's designed to have that consistency between multiple microservices that might be involved in the same overall process or transaction. And as I mentioned, this is really about relaxing those constraints of ACID. So this time we don't use ACID as the guiding principles. Instead, we use something called BASE, because again, we love acronyms. So BASE, again, relaxes things like consistency and isolation, hence why I've crossed those out and sort of highlighted that. In this, our applications or our microservices are basically available. They have a softer state, and they are eventually consistent. So this is one of the big differences between the two, is this eventual consistency rather than our strict, strong consistency of ACID. But as a result, we don't have as much isolation, we don't have as much resource locking, and so our applications can remain consistent even if something were to go wrong or get stuck in some kind of process for a transaction. So in this regard, when we're looking at Saga transactions, we're much more aligned with an AP system if you're looking at something like the CAP theorem, and because we're really having that eventual consistency, so we're prioritizing the other two. If you've not come across the CAP theorem before, definitely go check it out online. It's really interesting. It's this theory essentially that we can't prioritize all three of these various components or behaviors. So we have to consider just prioritizing two, and then we align more with these sort of either CA, CP, or AP systems. So it really depends on what you need in your application. In Saga, it is what we call a forward strategy. So in ACID-based transactions, if something were to go wrong where you can't go ahead with the transaction, for example, because one of the components isn't available or that resource isn't available for you, then what we do is we'd have a rollback, and you'd roll back what you'd previously done in other microservices to basically cancel the transaction. That doesn't happen in Saga. It's forward strategy. So we don't undo actions. Instead, we have compensating actions. Now, what occurs as part of that compensating action is really up to you. It can do exactly the opposite of what your action did, and so therefore undo your action, but we're not undoing specifically. We are just having that compensating action. So I've got an example here where you can see the original actions in blue and the compensating actions in yellow, but really it's up to you as to what those compensating actions are and what business logic you put in there. But this is essentially how we'd undo it if our transaction was unsuccessful. In Saga, there are two different approaches that you can use in terms of coordination, because we still need that consensus. We still need all of those microservices to agree, for this transaction to go ahead. It's still the same. It either goes ahead or none of them do. So there's two approaches. One is choreography and the other is orchestration. So choreography is where we have no central coordinator. Instead, essentially, all of the microservices that are involved in your transaction will produce some form of event that then triggers the next microservice in that transaction. So this is, I would say, more recommended if you have fewer number of microservices, so you don't have too many, because it can be fairly easy to set up. And if you get to a point where you have lots and lots of microservices involved, it can get quite complicated quite quickly because there isn't a single point of truth in terms of the state of your application. And yeah, it can be tricky to essentially follow that logic through when you have lots and lots of microservices involved. But this is a very agile approach, and it is, as I said, ideal if you just want to get simply up and running with a small number of microservices. So this is one to consider. The other approach is orchestration. So this is kind of more similar to the ACID transaction that I showed before, where we have this central coordinator. So this is essentially that single point of truth, and this is what coordinates and keeps track of the state of each of the microservices involved in the transaction. So the advantage of this is that you have this central point of coordination and this sort of central point of truth. It stops things like cyclic dependencies. With this approach of choreography, sometimes it can create stronger dependencies, and so kind of coupling sometimes between the microservices if you're not careful, whereas that doesn't happen within this approach. And if you have lots of microservices involved, I would tend to go down this route because the other one can become very complex. But the only thing with this that you need to consider is that we do potentially still have that single point of contention, that single potential bottleneck. I would say that it's kind of a trade-off, really, depending on how your application behaves and what kind of transaction you're trying to do. But the nice thing about Saga is that because it's been built with cloud native in mind, the implementations of this have behaviors and features built in that are sort of there because they know that that microservice might go down at some point, and are there to negate that becoming an issue or a potential problem. So there are steps that are making it less painful perhaps than it might have been if you were just to use something like ACID. But this is the second approach. So how do we go about using Saga? Well, it is just a sort of general set of guiding principles, so we'll need some kind of implementation. So the one that I was going to showcase today is Eclipse MicroProfile. Has anyone come across Eclipse? Yeah, got some hands. Cool. There's actually quite a few. So for anyone who's not come across Eclipse MicroProfile, this is an open source specification. Now, I'm focusing on this today, but there are other sort of frameworks that you can utilize if you're interested in Saga. If anyone is developing with Spring, for example, there's Axon Saga that you can take a look at. There's also things like Eventuate, Tram Saga, and Ciata. So there are other projects you can use other than MicroProfile. But MicroProfile, as I said, is really an open source specification that is designed to help developers who are developing on Java EE or Jakarta EE, so enterprise Java, to build effective cloud native applications that utilize sort of the microservice style architecture. And it is built by a wide variety of individuals and vendors, some of which are up here, and lots of these vendors help to produce some of the implementations that are available. This is not an exhaustive list, this is just some of the implementations of MicroProfile. The one that I helped to work on is Open Liberty, hence the t-shirt, and it's an open source runtime that you can use. So that's the one I'm going to be using for the demo application. So if you want to check it out, you can head to openliberty.io and see all of our guides, for example, if you want to get hands-on. One of the guides is actually using JCache and Hazelcast, which I'll link to at the end. So if you are interested in checking out how you could use caching in a more cloud-native manner, I definitely recommend checking that out in our guides page. You can, at the moment, only run it locally, but a lot of our other guides you can run in the cloud, so you don't have to have any prerequisites on your local machine. So MicroProfile brings with it a whole host of different APIs that you can take advantage of when building cloud-native apps. The sort of weird pyramid-y shape thing on the bottom that I've created is the APIs that come as standard as part of the standard MicroProfile stack. And it includes many APIs that are in common with things like Jakarta EE. So most of the ones on that bottom line there are shared between Jakarta EE and MicroProfile. But it also includes things like APIs to enable external configuration, to enable the monitoring of health and metrics when your apps are distributed. But the one that we're specifically interested in for Saga is in the top right here, the one that I've highlighted, LRA. So this is part of the standalone projects that the MicroProfile community still develops, but aren't yet part of that standard stack. So LRA stands for long-running action, and this is essentially what can be used to enable Saga transactions within your applications. So because MicroProfile is a specification, you'll need an implementation to be able to make use of it. The one that I'm showcasing here is Open Liberty, but there's lots of others that you can use. In Open Liberty, we're utilizing the Narayana implementation of long-running actions. And at the moment, just a general note, you will need to use the Open Liberty beta to be able to make use of this if you want to. So in this, we're using more of the orchestration approach. So we have a central coordinator, and the second part is essentially any participants that we want to be involved within a transaction. And it's fairly simple to get started with this. You basically just need to install features within your POM and your server.xml, and then utilize the annotations that MicroProfile provides through LRA. So as an example here, I have a demo app. So you can find it by visiting this blog, but I've also got a link to it in a later slide. And this is a basic application that is based on a holiday booking service, again, just to make it simple for you guys to follow that sort of analogy. So in this is my server.xml. So I need to add the MicroProfile LRA coordinator feature. As a general note, if you are playing around with this, there are two dependencies for this feature, and that is CDI and JAX-RS, so that's why they're also listed there within my server.xml. But it's fairly easy to get this coordinator up and running now. All we need to do is run the commands, run LRA coordinator and start LRA coordinator, and then our coordinator is up and ready to go. When it comes to participants, this is where we can utilize those annotations that I mentioned. So there are about 6 different annotations available at the moment. There are 3 that are the basic ones that you need. These are the minimum if you are going to have your microservice join as a participant. We've got @LRA, @complete, and @compensate. @LRA essentially determines that that microservice is going to be part of an LRA in some form or another. And as the names kind of suggest, @complete is essentially any business logic that needs to be completed if the transaction is successful, and @compensate is that compensating action that I mentioned. So what happens if the transaction isn't successful and we need to then compensate and use those compensating actions? So that's the business logic there. So what it looks like when it actually comes to the code is something like this. So this is all part of the same class. I've just sort of copied and pasted it into different screenshots to fit it on one slide here. But essentially, we've got that @LRA annotation right at the top of our class. And then further down, we've got the @complete and the @compensate annotations with that corresponding business logic. Now, you'll notice with the @LRA annotation, I've got this LRA type within it. This essentially determines how our microservice is either going to join or create an LRA. So there's 3 different types that you can use. There's requires new, or mandatory. So we're using required here, and essentially that's the middle ground. So what required says is if there's an existing LRA, just join that LRA. If an LRA doesn't exist, create a new one. Mandatory is essentially where an LRA has to exist for it to join. It can't create a new one. And requires new, as the name suggests, means that you create a new one every time. So you can use these different types to be able to specify how you want your transaction to essentially sort of come about and how your microservices are going to join that. As I mentioned, there are additional annotations that you can make use of within MicroProfile LRA. So we've got things like @forget, @leave, and @status. And this is kind of where I was going with the whole, they have built this in mind of cloud native. So for example, @status can be used to essentially report the status of a particular microservice. So if, for example, your coordinator were to go down, we could potentially use this annotation to reestablish the status of each of the microservices involved in that transaction to be able to then continue from there. And for example, we've got @leave. So if, for example, I want to change my transaction, so now I don't want to have things like the taxi involved because I don't want a taxi anymore, I can essentially use this annotation to remove that from my transaction. So as I mentioned, we have a couple of demo apps for this. So if you are interested, please go and check these out. So there is one with Open Liberty and LRA, which you can access through GitHub here. And this, as I mentioned, is a holiday booking application utilizing Open Liberty and MicroProfile LRA. I also mentioned that we have some guides that you can make use of. So if you are interested in any of the other MicroProfile specs that I didn't go through, we have a guide on each of those. And the ones that say run in cloud are the ones that you can utilize our cloud environment. So you don't have to have the prerequisites locally. Now, there is a specific one I would point out for this particular session, which is utilizing Jcache and Hazelcast. So the reason that we're using both is essentially because you need an implementation to be able to use Jcache. So in this case, we're using the Hazelcast implementation. This one you actually can't run on our cloud native environment as of yet, so you will need to run it locally, but we have provided information about the prerequisites you'll need in the top left-hand corner. And essentially, it's a set of instructions that you'll work through, explaining sort of how you can utilize this and why it's useful for cloud native. And then you'll have the classes on the right-hand side so that you can see what code you'll need for each. So yeah, that would be one that I'd point out. But we do have a whole persistence sort of section. You can see the different sections here with other persistence guides if you're interested in them as well. So hopefully that's sort of my whistle-stop tour of this subject. Hopefully what I've shown you is that stateful microservices are still needed in this cloud-native environment in some situations. I don't want to say that stateful is always the way to go, but when you really do need state, traditional mechanisms aren't always best suited for our cloud-native world. Utilizing mechanisms and techniques that have either evolved for the cloud or are based on cloud-native infrastructure enable us to be able to build effective stateful cloud-native apps. And there's a bunch of open source available if you do want to have a go with it yourself, things like MicroProfile LRA, Hazelcast, and Jcache. If you are interested in sort of revisiting any of this information, my colleague Mary has written this article which essentially summarizes everything I've been through within this presentation. It's available through the Java Advent sort of stuff that goes out in December. So this came out last December. So you can visit that URL there. Or, because I haven't given you enough homework already, more homework, if you really are interested in the subject, we have the blog that I mentioned that links to that application, that demo app. There's also another sort of microservice-based application that utilizes Open Liberty MicroProfile and runs it on Kube that my colleague Mary's made, and that's the second link there. If you're interested in finding out more about Saga itself, then we've got a couple of useful ones. It's the third link and the last link. And then if you're interested in finding out more about the MicroProfile LRA spec, then definitely head on over to the documentation for that, which is the second last link there. If you want to have a go with any of the open source that I've mentioned throughout, whether that's Open Liberty or whether that's MicroProfile, for example, these are some useful links to follow. There are starters for each of them. So if you've never used this technology before, head on over to the starters. With a few click down options, you can essentially get started with an application given to you in a zip file. So you can get started in 10 minutes. So it's really easy to do. And if you want some more information about any of the other MicroProfile APIs that I mentioned, there is the second link down is a series that goes through each of those. So with that, I'm going to say thanks very much for listening. And if you do have any questions that you want to ask, feel free to come up to the front. If you have any questions that you think of later, feel free to reach out to me on Twitter. My Twitter handle's there. And because I've had this question before in other talks, I've learnt, here's the slides in case you want those. I've already uploaded them. So you can either use, hopefully this QR code works. Please let me know if it doesn't. If not, I've put the link directly there as well, and I will share it on Twitter just in case. Thanks very much for listening.